All right, thanks a lot. So, bonjour and good afternoon, everyone. So my name is Matthias. I'm the CEO and one of the founders of a company called Space Optix, which is a Fraunhofer spin-off that targets to launch hundreds and one day maybe even thousands of optical systems into space. So I'm very glad that the speakers in front of me already showed the issue of having large amounts of satellites in the space in the future decade. So space is the future physical channel to enable human technological megatrends that count for artificial intelligence, the Internet of Things, and autonomous driving cars. Enablers will be small satellites flying in constellations, which use optical technologies to acquire and exchange data between the satellites, but also to ground. Those developments puts quite a demanding challenge on the technology we are using. So as the number of systems increases, the costs go down and we have to pack it into smaller volumes. So what does it mean for optics? Well, we actually want to have nanometer precision versus a production in series, and all has to work in space. So what we propose is to use metal optics. Metal optics feature unique properties for the new space market, such as reduced production costs and scalability to high volume manufacturing. You can easily manufacture freeform optics, which are weird optics, which allow the optical designer to shrink down the volume and to reduce the mass. And at the end, our technology enables a very fast integration of those systems so that you can assemble very complicated telescopes within hours. Space Optics, as a spin-off from Fraunhofer, wants to provide you the following services, starting from engineering and manufacturing, helping you in the optical design, going over to the manufacturing of the single components enabled by CNC machining, diamond machining, polishing, and figure correction. We produce optical components and mirrors, mainly for use for space, but also for astronomy applications. At the end, we end up at telescopes, cameras, and spectrometers on the system level. Metal optics are developed for a couple of decades already, mainly for the aerospace and defense market. So we have four major technology innovations that drive our optics. So one is an thermal material combination, which allows you to extend the range of temperature for the range of operational temperatures. Second one, we're really focusing on freeform fabrication, which means you can shrink down the volume and the mass of the systems. We're even able to print these mirrors, so allowing us to use bionic topologies or to optimize the structural of your optical hardware. And at the end, as I said, we can even integrate those systems very fast and effectively using kind of plug-and-play assembly approaches. Our technology already flies in space. So through our work in the Fraunhofer Institute, we have space heritage on TRL 9 level. On the left, you can see an imaging spectrometer. It's called DESIS, which is actually currently flying on the International Space Station, delivering images here of about 400 kilometer height from Earth. But we also developed optics for longer missions, like for Baby Colombo to Mercury and like JUICE going to Jupiter. Our team consists of 4 members coming from the Fraunhofer Institute, really focusing on fabrication, testing, and integration of optical systems. So Matthias and Marcel, we have an engineering background. We have 2 additional founders that have a background in fabrication and mechanics. And we're also supported by a team focusing on communication, marketing, and on business development. At Space Optics, we want to have 3 business units. Our main focus is the fabrication of optical mirrors and mirror systems for space applications, including the engineering and the manufacturing. Here we want to serve the major customers doing customized solutions, like also in traditional space approaches. Over time, we also want to develop a series of standard products for optical technologies, being able to enable mass customers for the new space market, where the technical requirements are oftentimes very similar. If it ends up really well, then in a couple of years, you just open up your Space Optics catalog and select your space-grade optical system right off the shelf. So at the end, please don't forget to push the buy button once you have put these 200 pieces here in the shopping cart. So at Space Optics, it's time for launch. we are very happy to talk to you at our small booth D19 and to take any questions that you have. Thank you very much.
Great timing, by the way.
I try to accelerate up a little bit.
This is quite impressive. It's also impressive what Fraunhofer, we know if they were not that good, one could hate them for being so good. What Fraunhofer puts out here, well, the fact that you got your own booth is also quite tough. You know, this is the Fraunhofer startups. They walk in heavy-handed. Good heavy-handed questions. Maybe time as a start. Now it starts being me again, being forced to ask questions. Maybe in terms of what's the market share which you're addressing? Second, what is the kind of funding and the amount of what's your planning and how are you planning to be financed?
Yeah, so our plan is to go to the market very quickly because we will have kind of a transition phase where we still will have access to facilities at Fraunhofer and at partners. Market share is a difficult question, which is I actually cannot answer very good. And for the funding, so at the end, if you want to set up such an optical fabrication chain with a lot of processes involved, you need about 5 or 6 million euros. So, but we want to start with a couple of processes on our own to be able to fabricate on our own and use also services from external partners.
For the total project, 5 or 6 million?
So for the total, let's say, machinery you need.
Okay. Hopefully Fraunhofer will fix it. I mean, you know, this is okay. Any more questions? Yes, Airbus. Airbus might fix it too, by the way.
So I get what you're selling, but what's your development journey? When will you start selling the first products, and what do you aim to do first in the process?
So could you repeat that? Or
the question related to first product sales.
Yeah. So what's your first product going to be, and what sort of customers are you targeting at the beginning, and then how will you scale?
So we could directly fabricate right from the beginning. So as soon as we found it, we're not even founded at the moment, then we could directly start up fabricating optical components and optical subsystems. So these will also our first product. So ranging from mirrors from millimeter size to half a meter size until subsystems like telescopes and cameras for laser comm, Earth observation, CubeSats, imaging, whatever. So the typical customers are still the big players in the market, which are Airbus, OHB, Thales, so the bigger players, and everybody who needs high precision optics and optical instrumentation would be our customer.
Okay. We have one more question from the gentleman with the fleece. I was trying to assess your...
It's the right assessment, yeah. It's a bit cold in here, but it's fine, yeah. So just to say something here, we are actually a company which are planning on having your first optics for our demonstrator. So when we launch next year, we're going to have a space optics on our demonstrator. Yeah. So we're kind of a customer, yeah.
Okay. Any more questions? Chris, great. Thank you so much.
Yep.
Thank you. Great pitch.